Hello everyone, today I will be solving question 2 in lecture 8. So the question says, in a hydroelectric power plant 100 meter cube per second, which is V dot, we know that by the unit, of water flows from an elevation of 120 meters to a turbine, where electric power is generated in this figure. The total reversible head loss in the piping system from point 1 to point point 2 is determined to be 35 meters. Head loss is 35 meters. If the overall efficiency of the turbine generator is 80%, estimate the electric power output. So W dot electric is required. Okay, so to begin with, actually we have the efficiency of the turbine generator is 80%. We convert it, so it's 0.8. We will be working on these two formulas, okay, and mainly on this one actually, and then when we get the W dot turbine, we're going to be able to find W dot electric. You'll see how later on. So here's a sketch. We will consider this point as the reference point. Okay, let's begin. To find W dot electric, we will say W dot turbine E will be multiplied by the efficiency of the turbine generator. Okay. How to find the efficiency of the turbine generator? It's actually, we have a part of it which is head loss here. To find the efficiency of turbine generator, we will say head loss multiplied by 9.81, which is gravity, multiplied by m dot. But at this point we don't have m dot, so what we're gonna do is gonna write m dot equal, it actually equals rho multiplied by v dot. V dot it's given, and we know rho. V dot it's 100, and the rho of the water it's 1000. So now we have m dot, which is 100,000 kilogram per second. Okay, going back to the efficiency of turbine generator, we can say again 35 multiplied by 9.81 multiplied by 100,000. Its value should be 34335,000 watt, and that's a huge number. Okay, at this point we have the efficiency of turbine generator, which equals to E dot mech loss, which we will be working on this huge formula. Okay, now that we got E mech loss, we can say, okay, at this point actually we're gonna be cancelling out so many things. And to begin with, we will cancel out W pump because we don't have it. Another thing that we will consider to be 0 is GZ2. Why is that? Because as I said, that's 0.2 at, at here, it's 0.2. The Z is 0 actually, so we can cancel it out. Another two things will be cancelled out is P2 over rho and P1 over rho. Why is that? Because here at point 1, the pressure actually acting on it, actually it's pressure atmospheric. So it's the same as the pressure acting on point 2. So they will cancel each out. So they gone now. Okay, what left is from this formula. Another thing will be cancelled out actually. Here, when we have this flow, actually the process of the water flowing through the turbine and then to the sea, actually that's sea and that's small lake. Okay, the water flowing from the lake to the sea, actually we cannot approximate a specific velocity, so it's almost zero, as same as water at this point in the sea. When it's increasing, we cannot estimate, it's almost zero. Okay, we know that there's a flow going through, and we know that sea level is increasing, but we don't know the actual number, so it's almost zero. So they will be cancelled out. What left is m dot multiplied by g z1 equal w dot turbine E plus E dot mech plus. At this point, m will be 0 for sure because all of that is 0. So multiplied by m dot, it's 0 obviously. So at this point, m dot is 100,000, g is 9.81, z1 it's 120, w dot turbine we will find later on. That's what we need to find actually. Plus E mech loss, as I said, the efficiency equals to the E mech loss, so it's 3435000. So going this way, W dot turbine E will be, or should be, 833,85000 watt. At this point, what we got is the power that is flowing inside of the turbine. At this point, I mean, we have the power, the actual number of the power flowing through. Okay, now that we got W dot turbine, we can go back to this. Okay, and we can say 8338500, and the efficiency was 34 35000. It should give us a number of, actually I calculated it to be a megawatt, not just watt, and it should be 66.7 megawatt. And that the electric output, that's the result.